Bismillahirrahmanirrahim, and hi, I am here to explain how to convert IEEE 754 32-bit floating point notation to its decimal equivalent. So, this is the example that I'm gonna consider. This is the 32-bit floating point notation in IEEE 754 format, and let's convert this to its decimal equivalent. In this format, state that the first bit is the sign bit, and this tells us whether the decimal equivalent would be a positive or a negative number. And since it is 0, so we can conclude that our decimal equivalent would be positive. If it is 1, then the decimal equivalent would be a negative. Next 8 bits are the exponent bits. These give us the value of the exponent of the number in scientific notation. So, let's convert the binary representation in its decimal equivalent just for the exponent. So, in this case, it is in binary, and converting this to its decimal equivalent would be 10 times 2 power 0 plus 1 times 2 power of 1 plus 1 times 2 power of 2, and so forth. We reach the last that over here would be 1 times 2 power of 7. So this will be 134. Now, we have to make sure that we deduct the bias from this value. So it will be 134 minus the bias, and we will get 7. Now, the third part is to figure out the mantissa of the number in the scientific notation and the fraction bit. So you multiply the first bit, that is 1 by 2 to the negative 1, multiply the second bit by 2 to the negative 2, you multiply the third bit by 2 to the negative 3, and so on. And then you add them all up to find the mantissa. The value is 0.6562. Now, to find the decimals equivalent, I am going to have the general form, and so the way you find out is by putting this into this general form, that is negative 1 to the power of s, where s is the sign bit, times 1 plus mantissa times 2 to the power of the exponent. So in this case, negative 1 times 0, then sign bit, multiply 1 plus 0.6562, then multiply 2 to the power of 7. Then the answer would be 212. Thank you for watching.